Okay, so let's probably get started. Good morning to all the heroes who managed to wake up early Friday morning and come here to listen more about programming. So this is week 3, lecture 3, where we go through some consolidation of what we have learned so far. Today is August 9th. What happened on this day in history? In 1173, construction of the campanile of the Cathedral of Pisa, which is also known as Leaning Tower of Pisa, Pisa, began. It will take 2 centuries to complete, quite a long time. In 1610, the first Anglo-Powhatan War began in Colonial Virginia. 2 centuries later, there were still American Indian Wars. The Creek, the indigenous tribe, signed the Treaty of Fort Jackson, giving up huge parts of Alabama and Georgia. So there was a long history of colonization. I would like to advise you to watch this wonderful movie, Killers of the Flower Moon, which was released quite recently. It's all about this history of America and the fights against Indian population there, the natives, I mean. So, yeah, this is really nice movie. Has anyone watched this already? Yeah. Did you like it? Okay. Okay, so in 1892, Thomas Edison received a patent for a two-way telegraph. In 1897, the first International Congress of Mathematicians was held in Zurich, Switzerland. In 1965, Singapore was expelled from Malaysia and became the only country to date to gain independence unwillingly. So, let's start with the class exercise that we have not finished on Wednesday. Then we do some recap of the material that we have learned, and then we go through some sample MST and exam questions, so we know the format of the questions. So, we finished on this class exercise. Has anyone tried this at home? So what we need to do, we need to find I such that the sum of 0 up to I will be greater than some given x. How do we approach this problem? So let me switch to, Grok. So we need to initialize x. Suppose we are provided x, which is 7. Then we also need to initialize I, right? Let's start with 0. And then what condition do we need? What do we need to put next? Who can tell me? There should be some loop, right? So what kind of loop do we need here? We have condition, right? So we need to check whether the sum is greater than x, right? So, and we will be in the loop while this sum is less or equal than x. So we need to have this while condition. While, and then what do I put next? So we have this I that we add iteratively here, but we also need to keep track of the sum, the partial sum. So let's put this as an extra variable. Let's call it sum. I'll just put it as the stacked assignment. And so while this sum is less or equal to x, what do we do? Wake up. What do we do? So we increment I plus equals 1, and we need to update the sum, right? How do we update the sum? Plus equals I. Okay, and once we are done, we can print the result. So what will be the result? So we need to, let's print sum, let's print I, and let's print x. So we can also put these partial sums here if you like to keep track of what's going on. So let's put partial. And we'll put this sum here, I and x. So let's call this thing. So we have this partial 1 and 1. So the first one is this partial sum. So it's first is 1, then it's 3, then it's 6, and then it gets 10. So do you think, is it correct or it's not correct? Can you evaluate this code? So we need I such that the sum is less or equals to the x. So here we have this sum, which is over here. We put it as the first one. It's 10. So does it satisfy or it doesn't satisfy? Wake up. Can you find a problem here, potential problem, any potential problems? Yes?
10 is greater than 7.
Yes, so how do we fix that? What do we need to do? So if you go, so we start with 0, so we have I is also 0, so, and then we go I increment by 1, so it will be 1, and then we have 3, and then we have 3 plus 3 will be 6, and then we have, is it satisfying or not? So then we have 3 and 6 and then 10. 10 is greater than x, 7. So is it correct or incorrect? What do you think? Can you evaluate this code? So we need to find I such that, the minimum I such that the sum is greater than x. So in our loop, we go through this while sum is less than or equal to x. So is it correct or incorrect? Can you evaluate the solution? How many of you think it's correct? Not too many. How many of you think it's incorrect? No one. So the answer is it's correct. Yeah, I made a joke on you. So this is correct. So we satisfied this condition. So we found I such that our partial sum is greater than x. This is the minimum I. So the I will be 4. That we get the value of the sum, which is greater than given x. So on the value of 4, so we get the sum, which is 10, and then we satisfy the condition that this partial sum is greater than our x, which is 7. Okay? So try to implement it at home again. So now the next one. So we have the sum of the digits of some big number is a. And then the sum of these digits of a will be called b. And we now need to find out what is the sum of the digits in b. So how do we approach that? So let's take, suppose, not that big number. And what do we need to do? The sum of the digits of something is a. So this is our number. So, and how do we find the sum of the digits of this number? What do I need to put? The sum of the digits of this number. I can put this in a for loop. I can transform this result into string and go digit by digit and sum the digits. So for I in, and then we transform this into string, and we need to initialize a. So, and now we need to accumulate. So we need to take each digit of this number and put this into a, right? So what do I put next? So I need to accumulate these partial results in A, right? So we take each digit, and of course it's string, so I need to transform this back into integer, okay? And then put this into A. Let's see if it's correct. So let's print the partial result, A and the number. So this is the number. It's 1,936, and the result is 19. Is it correct? Can you evaluate it? The sum of the digits, so it's 1 plus 9 plus 3 plus 6 will give us 19. It's correct. So now, what do we need to do next? We need to sum the digits of A and put that into B, right? So what do we need to do next? So we also have B. Let's initialize it here. And then we go through this again. For I in, and then we take A as our input, and what do we need to do? What goes next? Wake up. It's the same thing, right? So we just have B plus equals, and then I. So in B, we will have the sum of the digits. So let's put it all together. So B will be 10, A will be 19, and the input was 1,936. So, is it correct? Can you evaluate it? How many of you think it's correct? So in B, we have the sum of the digits of A. Okay? So let's move to the next part. So let's do the recap very quickly. So we already discussed what programming is all about. So a program is a set, yes?
So just on that previous example, when you have 4,000 power 4,000.
You want to see what happens?
Yeah, I was getting an integer overflow, and I was wondering, is there a way to...
Yes, there is. There is a way you can set up this sort of like the largest number in the Python settings. Yes, you can overcome this overflow. But again, you have some limitations, which is your operative memory, the RAM. Okay, so what is a program? So program is a sequence of steps, right? So we need to go step by step from the initial state to our desired state. And the program is expected to terminate, of course. So, and we also discussed literals and variables. Who can remind me what is a literal and what is a variable? Can you give me an example of a literal value? Any? Yes? Yeah, it's like particular string, like hello world, for instance, or it might be a particular number, such as 1, 2, 3, or 1.5, or it's true or false, depending on the data type. And what is a variable? So this literal, yes? Sorry? Yeah, so we have this like named objects in the memory. So we have these literals, they are stored somewhere in the memory, and then we can say this object in the memory will be called A. So we perform this through assignment. So, and we have the assignment operator. So let me just go to this terminal and demonstrate this. So let's increase this a little bit. So we have A assigned to 3. So what it means, we have 3 somewhere in the memory, and then A as sort of like a pointer to that memory cell. So we can always ask, who are you, 3? And we also can ask, who are you, A? So you see that they are pointing to the same memory cell. And it's crucial to understand that 3 is not copied inside of A. So A is just like a pointer to that memory cell. So if we perform something like this, how many objects in the memory will we have? If we introduce B and assign it to A, how many objects in the memory we will have? Who thinks it will be 2 objects in the memory? One for A, another one for B. Who thinks it will be 1? Yes. So the truth is that there will be just still a single object in the memory. We can check by asking, who are you, B? You see that it's pointing to the same memory cell. The ID is exactly the same. So you'll have 2 references to the same memory cell. So memory cell is 3, and you have A and B together pointing to that memory cell. So this is what I covered. And what happens in the assignments? So when we assign something to the variable, so the right-hand side part is evaluated first, right? So we take this, in this example, A assigned to 1 plus 5. So this 1 and 5 will be put in the memory. They will be integer data type, right? Then what do? We perform this plus. How this plus operator is interpreted? It's interpreted as addition, right? Because both operands are numbers. So, and we perform the addition, and we put the 6 somewhere in the memory cell. And since no other variables pointing to 1 and 5, we just remove this. There's a garbage collector that eats this object. So we only have now 6 in the memory. And then we see that we finish this evaluation of the right-hand side part, and we put the result into A. So A will be pointing to 6, and it will be dynamically assigned to the integer data type. So, and then we assign B to A. It means B will also be pointing to the same memory cell. So what happens if we now change the value of A? Suppose we add 0.2. Who thinks that B will change as well? Who thinks that B will not change at all? So the trick is, so let me just update it here. So A is assigned to A plus 0.2. Of course, the value of A and the data type of A will change. We see that now A is pointing to a very different object in the memory. B, what happens with B? B did not change. Okay, so in Python, whenever you update one variable of this immutable data type, so it means if there is another variable pointed to the same memory cell, it will not change. It's for the case of immutable data types. So what will happen here? So we take the 0.2, put it somewhere in the memory. We assign this memory cell the float data type, and we take the value of A. We retrieve it. It's 6, right? We start with the right-hand side part. We evaluate this expression. We get the result 6.2. And what happens next? We assign it to A. So A will be then pointing to the new memory cell where 6.2 is. And then B will still be pointing to the initial memory cell. Okay? So here I have 3, so it's kind of different number, but the same result, right? So you mean A will change, B will not change, okay? So, and A will also change its data type. So try to go through this at home. So what happens here? So this is stacking assignment. So how we interpret this stacking assignment? So we have 3 variables, A, B, C, and we want to assign all of them to the same value. We can do this in the very compact way. So A assigned to B, assigned to C, assigned to 1. So when we decide to update all of them, and suppose we would like to change them to the sum of A, B, C, so what happens first in this assignment, in the second one? So again, we start with the right-hand side part. So we take the old values of A and B and C, which is 1. So we take the sum of 3 ones, so it will be 3. And then we update these values of A, B, C. So A, B, C will be 3 after that. Okay. So we can also use assignment in this way. So in this case, we need to have the same number of operators and these values on the left and the right-hand side part. So on the left, we have variables. On the right-hand side part, we have literals. So we need to have the same. So A is assigned to 1, B is assigned to 2. Okay? So what happens if we do not have this match? Suppose we have something like this. Will it work? Will it work? Who thinks it will work? Who thinks it will not? So yeah, it will not because the Python interpreter is not aware what should happen. What do you mean by that? So, and if we do the opposite, if we put something like this, so will it work or not? So this construction will work, and we already started this data type. Which data type will we have for A in this case? Yeah, this will be a tuple. So A, you see that it appears in the round brackets. It will be interpreted as A assigned to this tuple. So, and again, when you perform such assignment, you need to make sure that you have one-to-one correspondence between variables and literals, right? The values that they assigned. You can also use this particular assignment to swap the values without the third variable, as Shannon already discussed it with you. So for instance, in order to swap the values of A and B, we can assign them to B and A, right? So we start with 1 and 2, and after this assignment, we'll have A assigned to 2 and B assigned to 1. Is it clear? Okay. And we already covered some basic data types. So which data types we covered already? Which data types you can name me? Which data type do we use for the whole numbers? Yes, integer, whether it's large number, whether it's small number, whether it's 0, whether it's negative, positive, it's just called integer, right? Which data type do we use for the real numbers? Float, yes, right. Again, positive, negative. As soon as you see the decimal point, it means it's data type float. Which data type is returned from if you perform just usual division? If I put 4 divided by 2, which data type will I get as the result of this operation? Float, correct. And what sort of division do I need to use if I want to guarantee that the result will be integer? Yeah, this is called float division, double division. So, and which data type we use for characters, strings, strings, text, and everything like that? I already told you. So it's string, called very literally string. So what else did we cover? Which data type we use for just Boolean values? True, false. This is called Boolean, obviously, right? And the other data type, the second data type, which is also called iterable, which is similar to strings. How do we call this? Where we can put together objects of different data types. If we want to return multiple values from a function, which data type do we use most commonly? It was covered in Wednesday Shannon's lecture. Which data type? Tuples, the one with round brackets and commas. So, and so I covered this, and this is an example of a tuple. Again, in tuple, unlike string, you can put objects of different data types. You can put together integer, float, boolean value, string, just put it all together and return. And it's, again, it's read-only. You cannot modify objects of this data type. And you can always ask what type are you by just calling the function type. And it returns you that this is an instance of the class tuple. Again, we will discuss what class means, what object means in the advanced lecture about object-oriented paradigm, because in Python, everything is an object. So what else do we need to cover? So we also discussed operator overloading. Who can remind me what it means? Can you give me an example of operator overloading? Yeah, so when we have this sign, plus sign, so if both operands are numbers, it's interpreted as addition, right? So we just 1 plus 2 will be 3. So if we now turn these operands into strings, what happens? It's concatenation, right? We just glue them together. Very different functionality. So this is called operator overloading. We use the same operator, plus, but depending on the types of the operands, it's either addition or concatenation. Who can tell me what will happen if I put one of the operands will be a string, another one will be integer? Will it work? Of course, it will not work because it's not defined for that. So you can also use this for tuples. You can put two tuples together. Oops, like this. So suppose we have two tuples, one containing 1, another one containing 2. We want to put them together, voila, so we have a single tuple. What was the other operator that we discussed in this context? What was the second one? Remind me of this, right? So it's multiplication, right? If it has two numbers, we just multiply these two numbers together. It can be integer, it can be float. It works. It can also work in this scenario when one of the operands is number, integer, and the other one is string. So what will be the result of applying this operator? What will happen? 2 times hello. What will be the result? Will it work? It will work. So what's the result? Hello, hello, right? We just repeat this string 2 times. And again, so it's, this particular operator is defined for the cases when you have integer and the string. But if you now turn this integer into string, it's not defined for that, right? It's not clear what do you mean by multiplying 2 strings together, right? It will give you an error. OK, so let's move further. So again, in Python, it's relatively straightforward in terms of the basic data types. If you then learn, say, C, you'll have to think very carefully which data type you use and how much memory you allocate. If you don't want to store a huge number, you'll just use something like char. So you need to think in advance how much memory you need for that particular object and how big the values might be. So in Python, this is all done automatically. There is dynamic allocation of the memory. So you don't really need to keep track of this memory usage. So we also discussed strings, and we said that strings are iterable data type. What does it mean? So you can iterate through the elements of this data type, right? So we can iterate character by character through the string. So what else can we do with iterable data types? So both strings and tuples are iterable, right? So we can iterate through the elements of a tuple as well. And we also can perform operations such as indexing and slicing. Who can remind me, what do we do when we perform indexing? Yeah, exactly. So we just provide the specific index, the location, and we retrieve element at that location. And slicing? Yeah, so instead of a single position, we have some range, right? So, and we discussed that all iterable data types, they again represented. So we have this sequence, and our indexing starts at the position 0, and we finish at the position length of the sequence minus 1, right? And in Python, we also have this backwards direction. We start with minus 1, and we end with minus length of the sequence. So this is the indexing. So we can use the square brackets to perform indexing, and we only need to provide a single number, which is the index, the position of the element that we want to retrieve. So, or we can perform slicing. In the case of slicing, we need to provide the starting index, which is by default 0, the ending index, non-inclusive. It's very important. Don't forget about this. It's not included. And the third parameter, what is the third parameter? Who can remind me? Yeah, this is our step, right? If it's negative, it means we are reading this string or tuple backwards. Okay, so we also discussed the Boolean data type, right? We use it in the if conditions, right? So, and we discussed two types of operators. One is comparison, and another one is logic. So what is a comparison operator? Which operators do you know? Comparison operators. Yeah, less than, greater than, less or equal, greater than equal, double equal, not equal, right? And logic operators, we use them in order to combine multiple conditions. When we want several conditions to be satisfied, we use these logic operators. Can you name me some logic operators? Yeah, and, so it's logical multiplication. It's only true when everything, every single subcondition is true. Or, right, it's logical addition. So we need to have at least one condition to be satisfied to get all the kind of construction to be satisfied. And then we have not, right? It's inversion. Not false is true, not true is false. So, and we can also convert other data types into Boolean. So in which case, for any number, do we get false? If you take any number, in which condition it will be evaluated as false? Yeah, it's only in the case it's 0. And for strings, what is this equivalent of 0? Empty string, right. So these are these comparison operators, and we have the logic operators. And finally, we also discussed the tuples. I already covered this. So it's iterable data type. It's very similar to strings, but unlike string, we allow objects of different types to be stored within a single tuple. And how we define a tuple, typically, yeah, you need to have a comma. So, and for the readability, of course, do not forget to put these round brackets to increase the readability. But still, if we even omit these round brackets, still it will be interpreted as a tuple. So if I ask, what type are you A, it will still be a tuple. Okay, so let's move on. So again, tuples are read-only, you cannot modify them. And next week we'll discuss mutable data types, which are modifiable. So, and then we'll discuss lists and dictionaries. There you can modify the elements of this data type. So here, if we try to take this, say, the very first element and assign it to something else, some other value, it will not be possible. So because, again, it's read-only. So, and finally, we also discussed the functions, right? So we use function to modularize our code, right? If we wanted to have some part of code to be reused for different input parameters, for instance, or reuse multiple times, we can define the function. So for function, of course, we need the function name, and we also need the body of the function. Optionally, the function might take some input values, or it might also return something. If you do not have this return statement, it will just return none. So, and on Wednesday's lecture, we also discussed loops, 2 types of loops. Who can remind me these types of loops? Yes? So for and while. So for is used when we know in advance how many times we need to perform some operation, or we need to go through some iterable object, such as a string. And the while loop is used in the cases of conditioning, right? When we have some condition to be satisfied. So, and a typical construction for the for loop is that we introduce this loop variable. This loop variable will be pointing to each element of some iterable object. So if here we have some string such as ABC, at each time step it will be pointing to A, then B, then C. And the while condition. So in while, we need to specify the condition that is evaluated either true or false. So while this condition is true, we perform the code inside of this while loop. So in this case, so while our length of text is not 3, we keep asking the user to provide something that contains 3 digits. Actually, we do not, again, check here that those are 3 digits. We just check that the length is 3. Or alternatively, you can also specify while loop in this way. So you can create this eternal loop while true, which is always true. And instead, you might have the condition inside of the while and use the break construction. So as soon as you reach break, you terminate the loop. It's similar to the return. So as soon as you reach return, you kind of terminate from the function. So now let's move to more interesting part. So I try to go very quickly because we are supposed to know this material already. So now let's do some practice. So let's prepare for the upcoming mid-semester test and exam. So I will only cover what we have learned so far. So you can, unlike in MST, you can chat with your peers who are sitting next to you. So for each of these exercises, I'll give you some time to discuss, and then you'll probably just, some of you volunteer to say the answer. So this is the first question. So you need to evaluate the expression. So you provided some single line expression. And you need to provide what will be the result of this particular expression, the operation. And make sure you specify the data type correctly. Okay? So let's start with the number 1. So I allow you maybe like 30 seconds to a minute. It should be relatively fast. Again, in mid-semester test and exam, you will not have your laptops. So try to use your pen and paper. No Python interpreter. So what will be the result of this operation? Haha, right. So what happens here? So we have the slicing, right? So we start at position -5. So we go -1, -2, -3, -4, -5. And we go up to position -1, non-inclusive. So we start at haha. And then we use this concatenation to attach the exclamation mark. So let me just copy this inside of interpreter so you can see that it's correct. I have some incorrect quotes here, unfortunately. I need to fix this. So this is the result. Haha. By the way, these are real questions from real mid-semester tests from past years. So the next one, 4 divided by 1. Looks very simple, right? 4 divided by 1. What will be the result? So it will be 4.0. Please do not forget that you need to specify that this is float data type. Do not forget to say that this 4.0. If you just say 4, it's incorrect, right? 4 means it's integer. 4.0 means it's float. So the next one, so we have bool, and we have C or I is greater than E. What will be the result of this expression? So we evaluate. So C is evaluated as how? True. And I is greater than E. Typically, even though the comparison is performed on the code points, it follows the alphabetical order. So I is greater than E is also true. So it's true or true, it will be true. The next one, so we have these 2 strings and some slicing and indexing. So who can tell me what will be the result? So we retrieve 3 to 6 and then -3 index. So this is cute, right? So we have 0, 1, 2, 3, right? We start with C, then we extract 3 characters, cut, and then we attach this E that is at position -3, okay? Now, the next one, completely different, not be seen. Not to be seen, so not to be seen as a string. What's the result? So this is false, right? So to be seen will be evaluated as true, not will be false. And then we have this AND operator, which means it's at least one false gives us false. The next one, 5 floor division 3. 5 floor division 3. What will be the result? Yeah, it's 1, just the whole part. OK, so let's go to the next one. So let me give you this expression. So it's a bit more sophisticated. So we need to keep track of the priority of the operations. So 5 times 6, then followed division 7 plus 8 modulo 9 division 10. What's the result? So multiplication and these types of division are the same order, and plus is evaluated after, right? So we need to first evaluate this part, and then add these results together. Anyone has an answer? Any answer? 4 and just 4 or something else? So what do we have here? So 5 times 6 will be 30. Then we have the floor division 7 will be 4, right? And then the next part, so it's 8 modulo 9. So what it will give us? 8 modulo 9. It will give us 8, right? And then divided by 10, it will be 0.8. So it's 4, 0.8. Then relatively simple example. So we have 12 as a string plus 2 as a string. 1 to 2, right. Then we have this string bird. We convert it into a tuple. And what happens next? We inverse it, right? So what will be the result? So it will be a tuple with these characters following the opposite order. Now the next one, hello, hello, and split by E. So we use E as a delimiter here. So what will be the result? It's actually the data type that we are about to discuss. It's list, and it comprised of these 3 strings, H, right? Then we have LLOH. Then we, again, use E as a delimiter, and the rest of the string, LLO. Now, OK, probably the most trickiest question to you. What is the maximum of the minimum as a string? Oops. What do we get here? So we have a string, right? And then we extract the maximum element of the string. So we perform the comparison on the character level, right? Again, we apply the comparison operators. Yeah, of course, it's you. The character with the largest code point, how it's called, character code number. And it follows, again, the alphabetical order, typically. So now the other type of task. So you need to come up with a single Python expression which relates to the following values. So you have the output value and some required operations that should be present in your expression. So we need to get true, and we need to use this comparison operator, greater or equal, and also we use string indexing. Can you give me an example of expression that uses these 2 operations and is evaluated as true? Any opinions? So for instance, what do we have? Say cat, we extract this indexing C. So we extract the first element, and we ask whether it's greater or equal, then say B. This is possible solution to this question. Again, it should be a single Python expression. Let's try the second one. So we need to get 4 using lengths and tuple slicing. So what do we put here? For instance, we can start with some tuple, like, for instance, this one. So we take, let's say, we start with the second element, right? We have 5 elements. We want to have 4 at the end, and we apply this length. Is it clear? OK, let's move further. So now we have this output value 34 as a string, and we need to use split and str. Here we might also use some other operation in addition. If you feel like you cannot come up with the answer, it's a bit tricky. We can, for instance, take some number, then we transform this into string. Again, these operations can be applied in any order. And what do we do? We can, for instance, insert something and use some split like this by this 6. And then we take, say, the very first. here we had this extra thing, which is indexing. It wasn't required, but we are allowed to use it if you need. So try to do that at home. Try to practice more at home. We'll also release some sample MST versions, so you can prepare for the MST, and we'll have a separate lecture about this. So another type of question, suppose we now have a variable called text. It's a Python string. We need to give a single Python assignment statement that creates a new version of text in which all the alphabetic characters are converted into lowercase, and in which all leading and trailing black characters have been removed. How we do that? Suppose we have text, which is hello, like with some extra spaces. So what do we need to do? What will be our solution to this? So we need to lowercase, and we need to remove all these blank characters. So first question, how we lowercase? Anyone? We need to recall the string methods, right? So there is a special method called lower. Oops, lower. Okay, so we lowercased. Now we need to remove all these extra white spaces on both sides. There is a special method that we can then apply to the string that is returned by lower. So we can just call strip after that. Okay? Of course, we can do the opposite order. So we can first apply strip and then apply lower. It's also a valid solution. So let's go to the next one. So suppose that top is a Python tuple. Give a single Python assignment statement that creates a new version of top in which the first element is replaced by special value none. With tuples, again, you need to remember this is read-only. We need to do something that is not just assignment of the first element to none. So suppose our top is like this, 2, 3, 3, or 2, 3, 4. So this is our top. Obviously, we cannot put something like this. This will not work because tuples are read-only. So what do we do? We need to recall concatenation of tuples. We can reuse this. So we can say that, okay, we have none as a tuple, and then we put tuple, and what do we need? We need to extract everything after the first element. This is one of the solutions to this question. So again, we take none, we put it as a tuple, and then we take the rest of the tuple, excluding the first element. And the resulting tuple will actually contain this none as the first element, and then the rest of the tuple. Okay? Is it clear? Let's move to the next question. So this is a very popular question in exams and MST, transforming for into while and vice versa. So suppose you're given some short code, and it contains for loop. You need to transform this into while loop. And everything else should be preserved. You should not change the functionality. You should get the same result with both versions. So let me just copy this into, say, here. And again, I lost all my spacing, unfortunately. So how I transform here for into while? What do I need to put? So here we have this loop variable in for I. So in while, we need to introduce this explicitly, right? So we need to say, okay, we start with 0, right? So this range will generate this range of numbers starting at 0 and finishing at length -1, right? So when we want to transform for into while, we need to introduce this loop variable explicitly. So, and then we want to do this while I is less than the length. we do something. But in the case of while, you also need to add extra line. You should not forget. It's not the whole solution, right? So what is missing here? So for increments this I automatically, right? In while, it doesn't happen, right? So because range, it will generate you the range of numbers. So in the case of while, it will not happen. You need to perform this increment operation by yourself. I plus equals 1. Probably have some issues with the, okay, so this is your solution. So when you transform for into while, you need to explicitly introduce this loop variable. You need to put the correct condition to finish the loop. And you also need to explicitly increment your loop variable. Okay? So try this at home. Let's move to the second part. So this one. How will we change this one? So we have for suit and suits. How we change this into while? So we cannot iterate like this in while. So we need to ask the length of the suits, right? So let me just go through this example, and then we probably finish because we are running out of time. And there probably is one more example that you can go through at home by yourself. Okay, so what do we have here? For suit and suits, if not color. This is so troublesome to recover this spacing. Return false. And then we return true somewhere over here. Okay, so what do we need to do here? So there is something that is called suits. So again, in these examples, you don't have to understand everything in the code. You just need to understand how you transform one loop into the other loop. So we need to have this suit or the index. So you can introduce the index I, for instance. Then we have the length of the suits. So we need to take, instead of iterating through this, we need to check the lengths. And then we want to have while, and I is less than the length of the suits. And we need to retrieve something. But now we have not suit, but we do not, we can access that elements of suits by indexing. So we need to get the index suits at the position I. And here it's the same. So we do not go through the suits element by element directly. We just retrieve these elements through the indexing. And again, we should not forget to increment I. Plus equals 1. So we have the suits as input, and then we take the lengths. This is our iterator, I. So it's initialized to the very first element, and we go through this. We retrieve this suit colors through the suits and this particular element of the suits. And we check the conditions. And again, every time we use while, we need to explicitly increment our loop variable I. OK? So please try it at home. And this one is also for your home exercise. So thank you so much, and enjoy the weekend.